let's focus on true bearings today. These can be a little bit confusing, but once you know all the tricks, you'll get the hang of it and you'll be all right. So, true bearings. A true bearing to a point is simply the angle measured in degrees, usually in a clockwise direction from the north line around to the direction that a point is in. Now, there are three things you need to know about bearings. The first one, they're always measured from north in a clockwise direction. The second one is they always have three numbers or three digits. So for instance, 270 is a bearing in degrees. Okay, if you had something like 65 degrees, you'd put a 0 in front to signify that it is a true bearing. And we also sometimes see that at the end we put a T. So for instance, 270 degrees true and 65 degrees true, that just indicates we're starting from the north direction and then going around to our point. So for instance, if you look at this diagram, we see that we have a bearing P from O. That means we're going to start at point O right in the middle. We're going to look where north is, and we're going to start there, and then we're going to go around all the way until we reach P. Now that's 65 degrees from the north line to P. So that bearing is 065 degrees. The bearing of O to Q, again, we look at O, we start from the north line and we go all the way around to Q. And that will take me about 300 degrees. So I put 300 degrees true. Have a note that when you see a point, say P from O, you always start at that second letter, so after the from. So you do it backwards. So you start from O and go to P. Let's have a look. Question 1, state the bearing of A from O. We're going to start at O, go from north clockwise direction all the way until we reach that line in the direction of A. Okay, obviously each segment is 90 degrees because that's the sections of our compass. So here we would have 90 plus 90 or 180, and then plus this angle right here. So if each quarter is 90 degrees, we'd have 90 minus 43, and that would give us 47 degrees for that little space. So to find that bearing, we say it would be 180 plus 47, so 227 degrees true. Next question, state the bearing of O from A. We've got to start at A, draw on my north line, and then go around. So I tend to draw in all points of my compass at A. North, south, east, and west. Now I'm going until I reach that point in the direction of E, so that line diagonally down. I might draw it a little bit clearer for you because that was pretty small. Okay, so my A is on the left, my O is down the bottom, and I know that I have the angle of 71 degrees in here. Now I can make a right angled triangle by simply drawing a line across. My first quarter from A, well, that's 90 degrees. If I keep moving clockwise, I have this little angle here that I'm going to find, and that's really just going to be 180 minus 90 minus 71 because of the angle sum of the triangle. That is equal to 19 degrees. So in total, the bearing of O from A is 90 degrees plus 19 degrees. So that would be 109 degrees. You can put the T in if you like. Alright, one more example. This one will be split into 3 parts. Here we go. About a bushwalker who's hiking due north from a resting place for 1.5 kilometers. They go to a waterhole. Then the bushwalker walks 2 kilometers on a true bearing of 315 degrees to a base camp. The questions that follow are all about this situation. So my advice, try and draw out that scenario, pause it, see what it looks like, and then come back and we'll go through A, B, and C. A bushwalker hikes due north from a resting place for 1.5 k's. So I'm going to start at my resting place. Let's call that R down the bottom. And I'm going to walk all the way up straight north until I get to a waterhole. Let's call that W. few more bits of information to fill in. Now, after I've got to W, I'm going to walk 2 kilometers on a bearing of 315 degrees to a base camp. Now it's 350 degrees that I'm going to walk on, and I'm going to walk on that for 2 kilometers until I reach base camp, and I'm going to call base camp just B. Okay. First question. How far west is the base camp from the waterhole in exact form? So if it says how far west, I'm looking for that horizontal line. And let's say that that point directly below base camp, we'll call that something like A. So I'm really trying to find A to W, or we call that X. Okay, this looks like a right-angled triangle, and it is. So BAW is 90 degrees. We have a right-angled triangle. Why A to B is north and A to W is west. I also know the hypotenuse is 2. I've just got to find that angle at the base where W is. So we know that the bearing from north W all the way around to the direction B was 315. I can find BWA, okay, by saying 315 minus 270. Because we'd have 90 plus 90 plus 90. That part here would be 270 degrees. Or 270 from 315. I will get my little angle BWA. And that will be equal to 45 degrees. Oh, how nice is that? Okay, so then you can find X however way you want. You can use sine, etc. Or you could probably use most trig functions. So I'm going to use cos here, okay, where I'm using that base angle. So I'm going to say cos 45 equals adjacent x on 2, rearrange everything. You can stick this in your calculator, but I do recommend knowing what cos 45 degrees is, and that's 1 on root 2. Okay, simplify it a little bit. If you want to get rid of the square root down the bottom, remember to rationalize. So you could write it as 2 over root 2, or that's just the same as square root 2 kilometers. Okay, so now I know what X is. Let's move on to B. What is the bearing of the waterhole from the base camp? So remember, we start with whatever is after the from. So we're going to start at the base camp, our capital B, and then we're going to figure out the bearing to the waterhole W. So at B, you might like to draw, again, your north, south, east, west. Okay, and we're looking for this angle here, from north to the line in the direction of W. And what you should notice is we have some alternate angles because both A to W and this B to a point, say M, are horizontal. They both go from west to east, so we have parallel lines. That means MBW should also be equal to, 45 degrees. All right, that's good. So then we have our bearing. Well, we have 90 degrees in the first segment, and then we have 45 degrees in the second segment. So our bearing of W from B is equal to 90 plus 45. Okay, last one. Let's spice this up just a little. What is the distance of the base camp to the resting place to 2 decimal places? So this is the direct distance. So let's let B and R equal some variable y. And I've got to find that length y in kilometers. Now I want you to have a think. Do you use the sine rule? Do you use the cosine rule? Can you use right angle triangles? What are you going to use to help you find this distance? Why? So here's our triangle. Let's put in all the sides, all the angles that we know. At W, I know part of it is 45 degrees. I know I have 1.5 kilometers and 2 kilometers as the sides, and I know I'm trying to find Y. I realized that I have included angle and I have two sides, so maybe I can use the cosine rule. Okay, I know that additional part of W must be 90 degrees, so that whole angle W is 135. Okay, let's use the cosine rule. So remember, y squared is equal to the adjacent sides squared, sum them up. So y squared is equal to 2 squared plus 1.5 squared minus 2 times the adjacent sides, 2 times 1.5 times cos of 135. Put it in the calculator and let's compare our answers. I got 3.239, or because we needed it to 2 decimal places, I should write it as 3.24 kilometers. Guys, go ahead and get started on 13F and be kind to yourself.